The world is undergoing a transformation so profound that it is being compared to the advent of steam power, electricity, and the digital computer. This is the fourth industrial revolution, or Industry 4.0, and it represents a fundamental shift in how we live, work, and relate to one another. Unlike its predecessors, which were defined by single breakthrough technologies, Industry 4.0 is characterized by the fusion and convergence of a vast array of digital, physical, and biological technologies, blurring the lines between these realms and creating unprecedented capabilities. This is not merely an incremental improvement in efficiency. It is a complete reimagining of the industrial landscape, promising to reshape every sector of the global economy and challenge our very ideas about what it means to be human. To understand the magnitude of this shift, it is essential to look back at the historical context that brought us here. The first industrial revolution, beginning in the late 18th century, was powered by the harnessing of water and steam, mechanizing production, and ushering in the age of factories. The second industrial revolution, around the turn of the 20th century, introduced electricity, which enabled mass production and the assembly line, fundamentally changing the speed and scale at which goods could be manufactured. The third industrial revolution, beginning in the 1960s, was the digital revolution, bringing us computers, the internet, and the digitization of communication and industrial processes, which allowed for unprecedented automation. Each revolution built upon the last, increasing productivity and transforming societies. Industry 4.0 is best understood as an extension and intensification of the digital revolution, but with a critical difference. It is about connection and intelligence. While the third industrial revolution introduced computers into the manufacturing process, Industry 4.0 focuses on connecting those computers to one another and to the physical world through the Internet of Things, IoT, creating cyber-physical systems that can communicate, analyze, and act autonomously. The term itself, Industry 4.0, was first coined in 2011 at the Hanover Fair in Germany, part of a government initiative to promote connected manufacturing and secure Germany's competitive edge in a rapidly changing industrial landscape. It was a strategic recognition that the future of industry lay in the digital convergence of processes, businesses, and entire value chains. At the heart of Industry 4.0 are several key technologies that work in concert to create this new paradigm. The Internet of Things, IoT, and its industrial counterpart, the Industrial Internet of Things, IIoT, are foundational. These are networks of physical devices, machines, sensors, robots, and even products, embedded with electronics, software, and connectivity that allow them to collect and exchange data in real time. In a smart factory, every piece of equipment, every component, and every product can speak to each other, creating a seamless flow of information that makes the entire production process transparent and responsive. This data, which is being generated at an unprecedented scale, is the raw material for the next critical technology, big data analytics and artificial intelligence, AI. The sheer volume of data from thousands of sensors is too vast for human analysis. AI and machine learning algorithms are essential for processing this information, identifying patterns, and extracting actionable insights. This enables a shift from reactive maintenance to predictive maintenance, where systems can anticipate equipment failures before they occur and even order replacement parts automatically, minimizing costly downtime. AI also powers the real-time optimization of production processes, quality control, and supply chain management, making decisions based on live data rather than static rules. As one industry expert noted, this move towards industrial autonomy replaces fixed instruction sets with control systems that continually adjust their behavior based on environmental feedback. This is where smart manufacturing becomes a reality. Another major pillar of Industry 4.0 is advanced robotics and automation. The vision is not simply to have robots perform repetitive tasks, but to have them collaborate safely with humans and be flexible enough to handle complex, varied work. These Cobots, collaborative robots, are equipped with sensors and AI that allow them to work alongside human workers, assisting with tasks that are physically demanding, dangerous, or require a high degree of precision. This extends to autonomous mobile robots, AMRs, that navigate factory floors, moving materials, and, in advanced scenarios, acting as mobile sensing platforms to collect environmental data and enhance situational awareness. This shift from simple automation to intelligent autonomy is a key theme of the revolution. Cloud computing and the related concept of digital twins are also central to Industry 4.0. Cloud platforms provide the massive data storage and computing power needed to process the immense streams of information from connected factories. A digital twin is a virtual replica of a physical product, process, or even an entire factory created from real-time sensor data. This is far more than a simple 3D model. It is a living simulation that can be used for everything from product design and performance testing to simulating production scenarios and optimizing operations. By testing changes in a virtual environment, companies can reduce risk, speed up innovation, and improve efficiency before making any physical alterations, cutting production time and costs. Leading companies are moving towards factory-scale emulation, where entire production environments can be simulated. Other technologies like 3D printing, additive manufacturing, augmented and virtual reality, AR/VR, and blockchain are also playing vital roles. 3D printing enables the on-demand production of complex parts and prototypes, reducing waste and allowing for greater customization and flexibility in manufacturing. AR and VR are powerful tools for employee training, remote maintenance, and providing workers with real-time data and instructions overlaid on their physical environment. Blockchain technology offers a secure and transparent way to manage transactions and track the provenance of materials throughout a supply chain, ensuring traceability and trust. The convergence of all these technologies is what makes Industry 4.0 so transformative. The benefits of adopting Industry 4.0 technologies are substantial and well documented. Companies can achieve significant cost reductions through energy efficiency, predictive maintenance, and optimized resource use. The early detection of potential breakdowns and the ability to monitor equipment health in real time leads to less unplanned downtime, which is a major source of lost productivity. Furthermore, the interconnectedness of smart factories enables unprecedented production flexibility. Traditional manufacturing was built on economies of scale, requiring long production runs of identical items to be cost-effective. Industry 4.0 changes this, allowing companies to respond more quickly to customer demand and efficiently produce smaller, customized batches of products or even single, unique items at a cost that was previously impossible. This is mass customization. However, the path to Industry 4.0 is not without its significant challenges. The upfront costs of purchasing and implementing new software, hardware, and infrastructure can be a major barrier, especially for small and medium-sized enterprises, SMEs. The integration of new technologies with existing legacy systems is another formidable hurdle, as machines from different eras often use different protocols, making communication difficult. This is slowly improving as standards emerge, but it remains a key challenge. Cybersecurity is a critical concern, as the increased connectivity that makes smart factories possible also exposes them to new threats. A cyber attack on a connected factory floor could have devastating consequences, from disrupting production to compromising safety. Furthermore, the complexity of these new systems creates a pressing skills gap. Workers will need new skills in data analysis, programming, and system management, and companies must invest in upskilling and retraining their workforce. There are also concerns about cultural resistance to change and the potential for job displacement as automation becomes more advanced. The impact of Industry 4.0 extends far beyond the factory floor. It is transforming entire supply chains, enabling end-to-end visibility and optimization that allows companies to manage inventory more efficiently, predict disruptions, and respond to market changes in real time. The COVID-19 pandemic dramatically accelerated this shift, highlighting the vulnerability of long, global supply chains and the need for greater resilience and localization. Companies are increasingly considering reshoring, bringing production closer to home and to their customers to mitigate risks. This new digital infrastructure also has a profound impact on the energy sector. The monitoring and analytical capabilities of Industry 4.0 allow factories to optimize their energy use, integrate renewable energy sources more effectively, and implement predictive demand management strategies, leading to lower carbon footprints. Governments are recognizing that AI and renewable energy are key to reducing carbon intensity, and Industry 4.0 is seen as a major pathway to achieving sustainable development goals. Even as organizations are in the early stages of Industry 4.0, thought leaders are already looking ahead to Industry 5.0. While Industry 4.0 is largely driven by efficiency, digital transformation, and economic growth, Industry 5.0 places a greater emphasis on the human element. It aims to foster a symbiotic relationship between people and machines, ensuring that automation works for the well-being of human workers. The goal is to leverage the strengths of both, the cognitive power and creativity of humans with the speed, precision, and endurance of machines, to drive innovation, sustainability, and resilience. Industry 5.0 refocuses on enabling people and machines to operate side by side effectively, with human-centric, resilient, and sustainability-aligned operations at its core. As the challenges of climate change, cybersecurity, and social inequality become more pressing, Industry 5.0 represents a vision for a future where technological progress serves humanity and the planet, not just the bottom line. The transformation is underway, and its outcome will define the next century of human prosperity and well-being.